Hello, this is Mr. Fry's Algebra 1 class, looking at what was done in class as I entered the class on March 15th, Monday. I believe this is due the back of this on the 16th, so that would be Tuesday. A couple of problems that we ended up doing in class. These were done on the board. But if you could at least get done, if you didn't see those during class time, at least get the ones that I am doing with you right here, get those done and get those turned in, okay? And then try some of the other ones on your own. So we're using the elimination method, so we're setting up the problem so that we can eliminate one of the variables. And here you can see that I have a 3x in this one and I have a 3x in this one. If I could change this equation and still, keep it an equation by, doing to one side what I do to the other. What I did was, if I changed this to a negative 3x, that would be great. So when I put these equations together, I'm just left with my y variable. So I do that. I multiplied, both sides of the equations by negative 1. And so this 3x becomes negative 3x. This negative 9y becomes positive 9y. This 15 becomes negative 15. And that's fine. I could do that. I could manipulate problems algebraically like that. So now I have a negative 10y plus 9y. So I have negative 9y, negative y. Negative 10 plus 9 is a negative 1, and I'm left with my y. 14 minus 15 is a negative 1. So I don't want to know what negative y is. I want to know what regular y is. So if I change the sign on this side of the equation, I need to change the sign on that side of the equation. And so I have y equals 1. I'm going to plug that y value in to one of the equations. Doesn't matter which one, because you'll get the same answer because they're both going to intersect at that one point, and it doesn't matter. You'll get the same answer. You could try me on that one. Put it in the other one. I put it in the second one. And so instead of 9x or 9y, there I have 9 times 1. This problem right here is what I'm talking about. Okay, so I just do the math. Get the variable on one side, divide both sides by 3, and I get 8 for my x. So my x variable, my x is 8 and my y is 1, so I write it like this, 8, 1. For number 4, and pause this as needed. For number 4, what I do is I change all the bottom once again. I change the signs or multiply each side by negative 1, however you want to say that, because my negative 2x becomes a positive 2x. Because I'm adding these two equations together, the system of equations. This positive 2y becomes a negative 2y. This positive 18 becomes a negative 18. I add them together. The reason I did that is to get rid of the y so I could just figure out what x equals. X equals negative 2. Now I plug in negative 2 into one of those problems. I chose the first one of the original problems. I chose the first one, and so instead of x there, you'll see negative 2 now. And I just work this problem out. 4 times negative 2 is negative 8. I add 8 to both sides. I divide both sides by 2 to get y by itself. Y equals 7, so my answer is negative 2, 7. On the back, it actually gets easier. So 4 minus 4x, it's all already set up. I don't have to manipulate the problem at all. These cancel out. So I could just figure out what y equals and then plug that in to figure out what x equals. So 9 plus 7 is 16. 5 plus 11 is 16. 16 divided by 16, y equals 1. I plug that into the first problem. This first problem here. Instead of y, now there's a 1 because I figured out that y equals 1. All right, 9 times 1 is 9. I bring everything else down. I subtract 9 from both sides. It becomes negative 4 on this side. Negative 4 divided by 4 to get x by itself is negative 1. So I have negative 1, 1. Try 6 on your own. Maybe after you're done with the rest of these odd ones so you could get more help. These are already set up too. Notice I have a negative y and a positive y. I don't have to manipulate anything like I did on the front page. It's just ready to go. 3x plus, and you're just going to add these equations up. So x plus 3x is 4x. 18 and 10 is 28. 28 divided by 4, x equals 7. I plug in that 7 to the first one. The first one looks easier. So I have 7 minus y equals 10. I subtract 7 from both sides. I have a 3 now. Negative y equals 3. I don't want to know what negative y equals. I want to know what y equals. So if I change the sign on this side, I have to change the sign on this side. So this positive becomes negative. This negative becomes positive. So I have y equals negative 3. So 7 and negative 3. Try 8 on your own, maybe when we're done. This one I did have to change. I did have to manipulate it a little bit more. And what I did was I just moved this 2x to be over my 5x. So if I'm moving it from this side to this side, meaning I had to subtract 2x from both sides. So I have a negative 2x now over here, and I still have my 4y, and I have my negative 8. I just rewrite this problem right underneath. Notice I have a positive 4y and a negative 4y, so I don't have anything else to do, no more manipulating to do. Negative 2 plus 5 is a 3x. Negative 8 plus 20 is 12. 12 divided by 3, I get 4, x equals 4. Plug that 4 in to one of the problems. I plugged it into that first one, and instead of x, now I have a 4. So I have 2 times 4 is 8. 8 minus 8 is 0. I just keep bringing that 4y down. 0 divided by 4 is just 0. So my y is 0. My x is 4. 4, 0 is the point where these two lines are going to intersect. That's what we're finding, the point of intersection for these two equations. If we were to put them in slope-intercept form and graph them, that's the point at which those two lines would intersect. All right, so this one I did manipulate down here a little bit, and notice I just moved the 2x over on this side, so I had to subtract 2x from both sides, and I still have my negative y over on this side of the equation. I had a plus 10. Notice everything cancels on this. 2x minus 2x, y minus y, and negative 10 plus 10, it all ends up being 0. What happens when that happens? It's infinite solutions. That means they're the same line. They're actually the same line. This one's just this line multiplied by negative 1, everything. So it's the same line. So infinite solutions. It's if you were to draw both of those, they would be on top of each other. It'd actually be one line. Hopefully this helped. Good luck with the rest.